At elementary statistics, section 9.4, two dependent samples, matched pairs. So once again, in the previous section, we talked about making conclusions about the mean of two populations and the comparison of it as independent, meaning there was nothing in common with them. Now we're going to talk about matching the pairs. So basically, there's going to be some sort of matching here. So they give us an example, kind of start with his dependents. They talk about match pairs of heights of U.S. presidents and heights of their opponents. So they could be talking about, the greater height or the taller the person, the more likely they are to win. And so basically, we can't compare somebody who was this height and opponent of this height because it doesn't correspond to what's overall being talked about. Now, if we talk about just heights of men and women, that would be independent because we're not comparing. Now, if we said heights of husbands and wives, that would be a dependent sample. So once again, we talk about male, female. But in this case here, we're just talking male, female overall, not matching them somehow. Okay, so when designing an experiment or planning an observational study, using dependent samples with paired data is generally better than using two independent samples. Okay, so as we're considering everything that's going on here, we do have to realize the fact that if we can compare things that are dependent, for instance, somebody on the drug, somebody off a drug in an experiment, and compare them directly as where they matched up previously as having same symptoms, same overall health, then we can truly see a little bit more effectiveness of a drug versus somebody who's healthy taking a drug and somebody who's not healthy that's not taking a drug. There's no comparison right there. So when we start looking at this, it's going to be a little bit different. Okay, our null hypothesis is going to be the mean difference equals 0. So that means the mean of one equals the mean of another. And then the other one talks about the mean difference is greater than or less than. Okay, so I'm talking about the mean difference. So this means that in our matched pairs, we actually are not going to be using lists or information of those actual numbers. We're going to be taking the difference between those two numbers in the pairs and then going in here. So for instance, on our data right here, if we look at this first one right here, 189 to 170, the difference is 19. Here the difference would be let's see here, a negative 12. Okay, because once again we take this minus this minus this. And so those are the numbers that we'll actually be using in this test when we have a matched pair. Okay, we're going to be using a t-test overall. Once again, confidence interval, our mean difference in here is going to equal our lower bound, upper bound, because that plus or minus our error in here. Now, caution. Okay, for interferences for dependent samples, match pairs, do not use our two-sample t-test or two-sample t interval for a confidence interval. Okay, this was for independent samples. Okay, so if we're doing the mean of independent samples, for dependent samples, okay, we're going to be basically entering our information into the lists. We're then going to calculate the difference of the two lists and create basically a third list on here for the difference. Then we'll calculate that third test or that third list under a t-test or a t-interval. Notice it's just one thing that we'll be working with. Now, we have to know the differences, okay? That's our whole biggest thing. But we always want to keep track of which one's our first one, which one's our second one, because if we're comparing greater than 0, less than 0, that means either one difference is larger, one difference is smaller, depending upon what is happening. So procedures. Okay, procedures. Verify that sample data consists of dependent samples or matched pairs, and verify that procedure requirements are satisfied. Find the difference, D, for each pair of the sample values. Find the mean of the difference then, and then find the standard deviation of the difference. For hypothesis testing and confidence intervals, use the same t-test procedures described in part 1. So once again, we're using our t-test. Now, there are some other equivalent methods. Because hypothesis testing and confidence intervals use the same distribution and standard error, they are equivalent in the same sense that they result in the same conclusion. Consequently, the null hypothesis that the mean difference equals 0 can be tested by determining whether the confidence interval includes 0. Once again, just a restatement of that whole procedure. And that's what this section really takes a look at. So it requires a little bit more work than just creating our list. We actually have to find the difference of it. So I'll be showing you how to do that in our spreadsheet or our list and our list app that we have on our TI Inspire CX calculator. And then everything is just calculated after that, and we test it the same. So nothing really changes except for the simple fact we have to add in an extra step now in our data part.